Hey guys, welcome to Functional Print Friday. If you like design and using 3D printing to solve real-world problems and not just printing trinkets, this channel's for you. So guys, I've been really excited about this week's video. For those of you that hung around to the end of last week's video where I did the hat hook, I give you guys a sneak preview of this. This is a fireworks controller that I built back in 2018. I designed and built this. In fact, this was featured on Hackaday at the time. So if you guys are regular readers of that site, you might remember it from back then. If you're not, check it out. It's a neat site. Probably a lot of crossover between just folks that are generally interested in 3D printing and engineering and the stuff that they feature on Hackaday. Anyway, I counted and I think there are 28 different 3D printed parts in this guy. Everything from completely functional, like this breakout board for the actual fireworks igniters, to some of the trim pieces on the case here at the handle. So let me get this out of the way and get this guy opened up, and we'll start digging into it. We'll start on the outside. This is just a wine box. This was in sort of my collection of boxes that I had sitting on a shelf somewhere. And I think it had the logo for the type of wine that this was stenciled on the top. I just sanded this off and then I printed a stencil. I 3D printed it. Wow, I guess that counts as 29 pieces I used for this. Anyway, I printed a piece of Banksy artwork as a plastic stencil and then just spray painted this on. I just thought the look kind of went with it. Thought it looked cool. So opening this guy up, we're going to quickly see the need for the first print. Being a wine box, this lid is just going to go all the way open and flop open. We don't want that for a couple of reasons, but the main one being this is a wired and wireless controller. So for the wireless part, we do want this antenna to be vertical. So what I designed here was a prop rod. It's got a holder here that it slides off of, and then there is another piece similar to this one down inside the case that hooks onto, and then that keeps the lid of this open. Second thing, and I've got to tip it here so you can see it, is up here. This is actually a holder for the ignition keys for this, and this is just a press fit. These guys just slide out of this holder. Go hard here with one hand. And these are the keys for the ignition, which we'll get to in a second. Up here on the top, this was just a generic wireless fireworks controller, and this was the original remote. I took the remote apart. Actually, let me get a screwdriver. We'll look in here. Okay, so this was, here, I'll hold it up so you guys can get a better view at it. This was just the inside of the remote control for the fireworks controller, and what I did is I basically just wired to the back of the circuit board so that instead of the button pushing to send the RF signal to detonate the firework or to light the firework, the button push is simulated just by a relay throwing and sending voltage to the pin on the button, the same as pushing the button itself would do. So this is obviously 3D printed. I just designed this to fit the size of the circuit board and then have integrated standoffs inside this box that this circuit board mount to. And you can see I've got a standoff here as well for the screw to hold this guy in place, and then there is a hole here in the cover plate that lines up with the LED so that I can see the LED flashing when that channel is activated. And this guy at the bottom, since there's just a single screw on the top, just has some pieces that stick out that fit into 3 matching holes down here at the bottom. So let's go ahead and put this guy back in place. Okay, next up, this is the battery that this guy runs on. This guy is battery powered, and this is just a small sealed lead acid battery. But there is a piece here that when this cover is in place prevents this battery from falling out. So I can tip this up. This battery is not going to go anywhere because it is retained by this piece here that mounts to this piece of thin plywood, and then has a piece that comes down over and holds that battery in place. Also on the top here is 2 knurled thumb screws and a little handle here to pull this lid up. And if you can see down here, there's just a strip of wood that this piece of plywood fits into. So if I take these two knobs off, it reveals some threaded 3D printed plastic posts, and we can just now grab this handle here, and this guy just lifts up, and then we pull forward on this piece of plywood, and then I can take this guy and fold it back, and you can see inside. Inside, obviously, we have these two posts with the threaded tops, and then underneath, it's a bit hard to see, but underneath each one of the boards in here is a plastic piece that is more or less the same shape as the board that is glued down to the plywood bottom of this, and has standoffs where all the screw holes are on the boards so that these boards can be swapped out if necessary. The boards are just screwed in on all four corners right into those mounting plates. It'll be easier to see those when we look at the design for this guy. Same thing is true for the Raspberry Pi. It also has a 3D printed base with little standoffs for each one of the screw holes, and for these guys back here. And there's a total of 24 channels on this. There is 12 that are wireless and 12 that are wired. The 12 that are wireless, those come up here through this wire. I think I actually cut apart an old parallel printer cable to have a wire that had, or to have a single cable that had enough individual wires for what I needed for up here. And then the wired channels, these are little breakouts that go from an RJ45, the same that you'd use for like an Ethernet cable, to little screw terminals, which is how I essentially go from send the signal here from the relays out to the individual queues. So the wireless ones, I should have grabbed those from my barn, but it's the receiver for these. It just looks like a little box with like 4 speaker terminals on it, and you wire your igniters directly into that. No change to those at all. But for the wired queues, let me set this guy back kind of roughly in place here. For the wired queues, you can see this plugs into the port on the back, or one of the ports on the back. In fact, these are color coded, so this one is blue, so I'd plug this one into the blue connector, and this is just a standard piece of, or standard length of Cat5e cable. Extra points for using one of my filament spools to wind this cable up, and then that breaks out to a terminal block over here, and all of the channels are numbered right on these terminal blocks. This is channel 19 through 24. I have another one of these that is the 6 channels underneath this, and then the 12 channels, channels 1 through 12, are the wireless channels. So a couple things here on the design. This is designed to fit these standard terminal blocks. This piece here isn't just for decoration, being a different color. There is a hole or a bore through this block for the Cat5e cable. It comes out here, and then this actually clamps down on it. So this piece, I don't know if you can see in that, it interrupts the bore a bit, and just tightening down on these 2 screws clamps that cable in there, sort of as a strain relief. So you can see, actually, if I pull hard enough, I can move it, but it basically keeps it in place. So I think that might be it as far as what to look at on here. As I mentioned, there's a couple decorative pieces on here as well, like the plates here that cover the holes where the rope handle comes through. And then also I have my initials on here as well. I think that's it for the 3D printed parts that are in here. Like I said, you're going to need to see, you know what, there is one more underneath here for the power supply, or the buck converter that powers the Raspberry Pi from this battery in there. Before we go take a look at the design elements of this, let's actually fire it up. I'll give you kind of an idea of, in general, how this works. Okay, all back together. So notice we have 2 switches here and a key switch. This first switch is just going to turn on our main power, which is going to feed power to the meter and over to the main power bus that feeds everything else in here. So by flipping the switch on, essentially, we're turning on the first step to powering everything else inside this unit, and also bringing power to the voltmeter over here so that we can see that we are in the good range, which I made a custom face for that gauge. That is just printed on a normal inkjet printer. Also has that same Banksy artwork, and then also a little green range there for what represents a good battery charge. The next switch is going to boot the Raspberry Pi inside this device. So if I've turned this on here, watch the meter. You'll see it's going to pull down just a little bit as the Raspberry Pi starts to draw power and boot up. At this point, everything is functional on here. Once that Raspberry Pi boots up, I can access the software running on here wirelessly, which I'll link to. I have a video on my other channel that I put out when I put this guy together that I think shows all of the more of the software and other workings of this. But I'll drop a screenshot here just on the screen so you can see what the interface looks like. Essentially, you're just joining the wireless network that this guy's putting out with your iPhone or iPad or whatever else, and then going to a URL, and it's just a simple web app that lets you either start a script that controls the show or interact with the individual channels on this guy. So notice I said everything is up and running. What's the key switch for? Well, we could go in, we could log into this, we could fire channels off, but nothing's actually going to happen because the key switch is what sends power to the relays and allows them to fire. So the signal will go to the relay in the state that we're in, but the relays won't actually send any power out to our wired channels or to the radio transmitter unless this guy is armed. And that's what the keys are for. So I could have this guy all set up, ready to go. I could grab the keys, put them in my pocket and walk away and not worry about anyone else trying to mess with this or fire off the show without me. So if I put this guy in and turn it, you see the LED light comes on and shows that we are armed. So, all right, let's go take a look at the different designs for this. And before we do that, I'll say, because I know a lot of people don't stick around long enough to see, what thought went into the design and the actual designs themselves. But I post all of the videos that I put out on this channel. I publish all of the STLs for you guys to download and make your own completely free. I mention that in the end of all my videos, but I don't think all you guys make it to the end of the video. But I have a site, fpfdesigns.com. It's linked right in the description of this video. If you guys see anything you like that I cover on this channel, the STLs will always be available and they will always be free. So check that out. Let's go take a look at the design. All right, before we take a look at those design files, let's go ahead and pick a winner for last week's giveaway. So in last week's video, I promised to give away a roll of the Hatchbox copper PLA filament. Let's plug in the URL from last week's video. Let's see, we want to filter duplicate users and answer the CAPTCHA. Looks like we've got 17 people entered to win. Let's go ahead and pick one. All right, CDs make stuff. You are the winner of the giveaway, so please go to fpfdesigns.com and scroll down to the bottom, hit Contact FPF, and reach out to me, and I will reach back out to you, and I'll verify it to you, and we'll get this sent out. All right, let's take a look at those design files. Okay, so here's all the design files for this, and many of these, there are multiples of them in the project. For example, starting down at the bottom left-hand corner here, this is the one that relay module attaches to, so we need 3 of these guys total for this project. Working our way up around, and I'll touch on any details if there's anything unique or specific. I guess starting with this one, so this center standoff here is just meant to support the board. So the 4 on the corner are the ones where the screws are going into, and you notice I rounded off the entrance there so that just a self-tapping screw can go in and just make threads in that hole. And then the center standoff is just to support that circuit board. So it's the same height of these guys, it's just the bare circuit board is sitting against that so that it doesn't bow down in the center when you're wiring up the terminals. This guy here is for the Cat5 or RJ45 breakout boards. 2 of these are used in the project. Notice these go right up against the edge of the case. That's why it's flattened off on that end. This guy here is for the Raspberry Pi. Working our way up, this is for that buck module that converts down to the voltage for the Raspberry Pi from the battery. And going back down towards the bottom here. So notice there's 3 different versions of this. This one is channel 13 through 18 with the channels molded right into the plastic. Channels 19 through 24. And then I do have a version of it that is just blank as well. So if you want to use this for your project and these numbers don't mean anything for your project, go with this guy, and you can either put stickers on it, write right on it with a permanent marker, or you can add your own raised lettering numbers on there as well. Notice these guys slope down in the back to give room for those wires to expand sort of in this tray, and the terminal block attaches down to here. Any of the special parts that I use for this, I'll make sure I link down in the description below of this video. So the specific terminal block that fits right into this guy, I'll link that. I'll link the relay modules. I'll link the breakout for the RJ45. Raspberry Pi, I mean, I'll link to one, sure, but just go with whatever the current version of Raspberry Pi is. I think they're hard to get right now for some reason. I don't know if it's pandemic has hurt the stock on those, but I tried to pick up another one for a project and I noticed they were quite pricey. And this last one is for the buck module. I'll link that guy as well. Those guys, on the other hand, are amazingly cheap. I can't believe some of the electronics, what some of the electronics components cost, particularly in the modules. You couldn't buy the parts to make your own for even close to what the whole module costs. This is the holder for the keys, the ignition keys, or the arming keys that are up at the top of the case. This is that pass-through for the rope handle. 2 of these guys are used. This is the hardware for that prop rod. The way that this goes together, these pieces actually, so this is the one that goes on the inside of the case, that the rod kind of goes over and then hooks down on so it can't fall off easily. This is the holding one up on the top side of the case. And then this is 2 parts here. So this piece, the prop rod fits around this larger diameter here, and then this is sort of a keeper that presses in. It's a press fit into here. Working our way over, this is the retainer for the battery, or the battery hold down clamp, I guess you could say. This face here is attached to the piece of plywood that makes up the lid. And then this is the piece that holds down the battery. And this is the case for the RF module, the transmit module for the wireless channels. And I will touch on a couple of the details with this one. So this hole was for that LED to poke through. This hole here is for that countersunk screw. And then inside here we have the standoffs for the board, which have a small ring that align them. And then it's sort of, well, it's a combination, I guess, of a piece that aligns it and then a standoff to hold it at the right height off the bottom. This also supports the board at the bottom end. This looks like this might have been an earlier revision on the design here. I'll fix this on the spot. This should be a hole going down for that screw to go into. So we'll drop that down to maybe about the center position. And you can see the notches down here in the bottom that the cover fits into. We have small pieces down here in that cover that key into those. And these are sized a bit smaller than the actual slots down here, so it doesn't get stuck in place. Oh, and last piece, I did find the stencil that I made for that Banksy artwork that goes on the top. So if I remember correctly, I sized this to fit to use as much bed space as possible, or as large as I could make this on a Prusa i3 Mark III. So if you've got a printer that has a bed the same or larger, you could use this as is. If not, you could just scale this down in your slicer to fit whatever the largest size you can print is. So guys, I hope you enjoyed that. I don't imagine many of you are probably going to build the exact same thing, but hopefully some of these parts are useful in your project. For example, these breakout boards could be used for all sorts of things, or another fireworks launcher controller. And these standoffs here are, I'm sure, useful for other projects, for the 8-channel relay module, the Ethernet breakout boards, stuff like that. Also, I forgot to mention, this piece here, as you could probably imagine, is the piece that fits down on here and locks that Cat 5 in. You can see just based on the diameter of the hole here, this guy just sort of clamps down on that Cat 5 cable to keep it in place. So this is fitting down here just like that. All right, guys, thanks for tuning in. I hope you enjoyed this. If you did, please give me a thumbs up. Consider leaving a comment below if you've got any questions about this project. And I post a new video like this every single Friday. So if you're interested in this type of thing, consider hitting subscribe. And guys, if you do, I will catch you next Friday.